Now we will see what is the meaning of factorial. You just encounter that 5 factorial is there. You just write like this or in this way. What is the actual meaning of factorial? This means it is 5 into 4 into 3 into 2 into 1. Or you can write this thing as 1 into 2 into 3 into 4 into 5 like this. Some small things I am doing here. If I have to write 6 factorial, see how can I write 6 into 5 into 4 into 3 into 2 into 1. So I can write this also like this. If I have to write 6 factorial further, I can write this thing as 6 into 5 into 4 factorial. We just stop at our convenience. Where we are feeling comfortable, we just stop. So n factorial can be written in this way: n into 1 less than n, that is n minus 1, 1 less than that, n minus 2, suppose up to 1s. Okay, suppose I want to stop somewhere, so I will write n minus 1, n minus 2 factorial like this. So be conversant with the conversion of the factorial terms in the comfortable terms. Okay, hope you understood about the factorial. Now we will do certain simple questions to understand factorial very clearly. See, first question: if 1 by 9 factorial plus 1 by 10 factorial is equal to x by 11 factorial, I have to find x. What can I do? I have to take the LCM, so I can convert this 10 factorial as 10 into 9 factorial. You know that bigger thing can be broken into smaller one. Never try to break the smaller things. Okay, so bigger is 10 factorial, so I broke it. Now we can easily take the LCM. What it is coming out to be? 9 factorial into 10. Okay, so what it is coming out to be here, see, it is just 10 and this is 1, x by 11 factorial. So we can easily get the value of x, that is 11 into 11 factorial divided by 9 factorial into 10. Further simplification gives us, if I just write, see that this is bigger one, 11 factorial. So I have to break this one. So if I just break, I can write 11 into 10 into 9 factorial. I will stop here because in the denominator 9 factorial is there. So 9 factorial into 10. This 10 is getting cancelled out. 9 factorial is cancelled out. So what is the answer? 121. So you are understanding this thing, how to make the application of factorial things. Second question: if n factorial by 2 factorial, n minus 2 factorial is 2, that means divided by. So we can write this thing divided by n factorial by 4 factorial into n minus 4 factorial is given 2:1. So what movement can we make so that factorial terms are getting cancelled out? See, I can just cancel this n factorial from this n factorial. So what I am left with? I am left with 4 factorial into n minus 4 factorial divided by 2 factorial into n minus 2 factorial is equal to 2 by 1. See, now which one is bigger, n minus 4 or n minus 2? N minus 2 is bigger. So we can break this and we can write it as n minus 2 into n minus 3 into n minus 4 factorial. Okay. and this is cancelling out now. Okay, now see which one is bigger, 4 or 2 factorial. 4 factorial, of course. So we will write 4 factorial as 4 into 3 into 2 factorial. Now 2 factorial is cancelling out. We can solve and get the value of n easily. Okay. See the next question. This is 2n factorial by n factorial is equal to certain thing I have to prove. So you know that 2n factorial, the meaning of this is 2n into 2n minus 1 into 2n minus 2, 2n minus 3, 2n minus 4, like this up to 6, 5, 4, 3, 2, 1. So what actually is happening? The thing is starting from the number itself, reducing by 1, 1, 1 and ultimately reaching to 1. And here I am just writing n factorial, doing nothing. So now see, how many terms are there in 2n factorial? 2n terms. How many terms are there in 5 factorial? 5 terms. So 2n terms are there, out of which n terms got a factorial, a factor of 2. That means 2 can be taken common from there. So if I am combining these things, the underlying things you see here, and I am taking 2 common. If I am taking 2 common here, it is n. 2 here, this is n minus 1. 2 here, this is n minus 2. Like this. And every term is giving us 2. So how many 2's are there? N terms are giving us 2. So 2 to the power n. And on taking common, what we are left with? N. Here, n minus 1. Here, n minus 2. Up to 2, 1. Like this. Okay? And we are just left with the odd terms. That means which are not giving 2 common. What that is? 2n minus 1, 2n minus 3, 5, 3, 1. Like this. Okay. And here n factorial is there. Now you see, this is n into n minus 1 into n minus 2 up to 1 is actually n factorial. So this can be cancelled out with this. Why? Because this is n factorial. So I am just left with 2 to the power n into, if I just write in reverse order, 1, 3, 5, increasing order up to 2n minus 3 into 2n minus 1. So we have proved this thing. Now go for the last question. Very simple, you can do it your own. See, in the last question, it is 7 into 8 into 9 into 10 up to 15. So if somehow it is starting from 1 to 15, we can write this as 15 factorial. So if I am just writing 1, 2, 3 up to 6 like this in the numerator and in the denominator to balance it out, because we cannot do anything extra in mathematics, we have to balance it out. Now the numerator thing is coming out to be factorial 15, and here it is coming out to be factorial 6. Hope you are understanding dealing with the factorial very conveniently. We will study the very basic of permutation and combination. If we know this theorem very well, we will find ourselves very convenient in solving the problems of PNC. So firstly, we have to understand what is basic multiplication theorem. Suppose I have to go from Mumbai to Kolkata. Okay? In between, Delhi is there. So from Mumbai to Delhi, if I can go in 3 ways, this is way number 1, A1, A2 A3, and from Delhi to Kolkata we can go in two ways. Can you tell me in how many ways, total ways, we can go from Mumbai to Kolkata? I have seen that students say this is 1, 2, 3, 4, 5 ways. But actually see how many ways he can reach from Mumbai to Kolkata. He can either go from A1, B1, that means from Mumbai to Delhi following the route A1, and from Delhi to Kolkata following the route B1. It can be A1, B2. It can be A2, B1, A2, B2. It can be A3, B1, A3, B2. So what actually you are seeing that he can reach from Mumbai to Kolkata in not 5 ways, is reaching in 3 into 2, that is 6 ways. That is the very basic of multiplication theorem, that if a part of work is done in n ways and the remaining part of work is done in n ways, then the complete work is done in m into n way. This theorem you will be using throughout your study of permutation and combination. Just see what I recommend you identify what is your task, what is your work. Suppose one question I'm taking, I have to solve 5 questions. Okay, multiple choice. Each question got 4 options. See in how many ways can we solve all the 5 questions, total number of ways. I just tell you, divide the actual work in subparts. So I have to solve 5 questions. So how many subparts are there? 5 subparts. 1, 2, 3, 4 and 5. Now see in how many ways each subpart can be done. So first question can be answered in 4 ways, because the person can select either option A, B, C or D. So 4 possibilities are there, 4 options are there for first question to be solved. Same way second question can be solved in 4 ways, third in 4, fourth in 4 and fifth in 4. So the total number of ways of solving 5 questions of multiple choice is 4 into 4 into 4 into 4. So I just say, wherever you have to solve such type of problem, identify the main work, divide it into subparts and then see in how many ways each subpart can be done. So you just multiply until your work is complete. One question I'm taking here, if I have to post 3 letters, okay, and 4 post offices are there in our locality. So in how many ways can I post all the 3 letters? So just read the question carefully. What they are asking, in how many ways can the letters be posted? So your work is posting of letters. You are not concerned about the post offices at the first instance. So the main work is posting of the letters. So you got 3 letters. So the work can be divided into 3 subparts. Letter 1, letter 2 and letter 3. Now as you got 4 options in your locality, so first letter can be posted in 4 ways. Any of the post offices can be used for posting the letters. Second letter can also be posted in 4. Third letter can also be posted in 4. I am just keeping on multiplying until my work is complete. When my work is complete, when I have posted all the 3 letters. So what it is coming out to be? This is coming out to be 64 ways. Suppose some restriction have been imposed that at a post office you cannot post more than 1 letter. At one post office you can post 1 letter. So in that case, be careful about the condition. First letter can be posted in 4 ways because no restriction is there. But now you see that second letter cannot be posted in 4 ways because 1 letter has been posted to a post office. So second letter can be posted in 3 ways because 3 options are left over now. And the third letter can be posted in 2 ways. So in this conditional counting, we see that letters can be posted in 4 into 3, that is 12 into 2, 24 ways. So be very careful what work you have to do. Divide it into subpart. Main thing is identification of work, then division into subparts, and then see each subpart can be done in how many ways. Hope you are understanding this theorem. We will see how to deal with the numbers with different digits in permutation. See, I have written a set of questions. By means of these questions, we will clarify our concept. Earlier we have seen how to complete the work. We have gone through M into N theorem. We will be using that and the basic concept of permutation. See, the digits 1, 2, 4, 5, 6. Find the total number of numbers with no repetition of the digits if no restrictions are there. See how many numbers are there? 1, 2, 3, 4, 5 numbers are there. Okay. So if no restriction is there, we can just form the numbers. I said you just make a box. That means the work is to make a 5-digit number. So just identify the 5 subparts of the actual work. Now see, this place can be filled up in 5 ways. This can be 4, this 3, 2, 1 ways. This box can be filled up in 5 ways. This box can be filled up in 4 ways. This can be filled up in 3 ways, like this. So the total number of numbers with no restriction is 5 into 4 into 3 into 2 into 1, that is 5 factorial. So you can easily find. Second question, 5 always occupy 10's place. See, again we will just make a box and 5 will be at 10's place here. That means this place will be fixed with 5. So this can be done in 1 way, and the remaining 4 places with the remaining 4 digits can be filled up in factorial 4 ways. So the total number of numbers is factorial 4. Okay. Now C part. Even numbers. Even number, you know that even numbers are those numbers which end with 0, 2, 4, 6, 8, like this. Here the available resources are 2, 4, 6. So this unit place can be filled up with either 2, 4 or 6. That means in 3 ways. Now you have used one of the digits 2, 4, 6. One digit has been used. Suppose we have used 2. Okay. So we are left with 4 digits now, and the 4 places are there. That can be filled up in factorial 4 ways. So the total number of ways is factorial 4 into 3. Now go for question number D. The number is, I am doing here D. See, we have done. So I am doing D here. Okay. The number is beginning with 1 and ending with 5. Okay. So the first place is 1 and the last place, that is the unit place, is 5. Okay. 2 places are fixed. This can be done in 1 way. This can be done in 1 way. Remaining 3 places with the remaining 3 digits can be done in 3 factorial ways. So the total number of ways is 1 into 3 factorial into 1. See, for question number E, the number greater than, it should be 40,000, okay, because this is a 4-digit number, 40,000. So the number has to be greater than 40,000. What does this say? This means that this place should be filled up either with 4 or 5 or 6. 4, 5, 6. Then only it will be greater than 40,000. So this place can be filled up either by 4, 5 or 6. 3 ways. So one digit have been used. Remaining 4 digit can fill up the remaining 4 places in factorial 4 ways. How many numbers can be formed by using any number of digits 310579 with no repetition of digits? Okay, see, it can be a 1-digit number, it can be a 2-digit number, it can be a 3-digit number, like that. Suppose I have to find 1-digit number, that means one box is there, that is to be filled up with the digits this. See how many digits are there? 1, 2, 3, 4, 5, 6, 7 digits are there. But 0 cannot be filled at this place because 0 won't be a number. Okay, so how many numbers are possible here? This is 1-digit number we can form by picking any of the digits. 7 digits are there, so 7 such numbers are possible. 1-digit number. Now I have to find 2-digit number. 2 boxes will be there. You know that this place cannot be filled with 0. So this can be filled in 6 ways. Why? Because 6 options are here. If we are filling 0 here, it won't be a 2-digit number. Now this place can be filled up in, as we have used one of the digit apart from 0. Suppose I have used 1. Now how many digits are left over? 1, 2, 3, 4, 5, 6. So this place can also be filled up in 6 ways. Okay. Same way, if we have to find the 3-digit numbers, what process we can follow? This place can be filled up in 6 ways. This place in 6 ways and this place in 5 ways. Like that, you go ahead, you will find the numbers with different digits. 1-digit number, 2-digit number, 3-digit number, 4-digit number, 5-digit number. Just take care of the first place. This should not be 0 here. Because if 0 is coming here, it won't be that digit number. If we are considering 3-digit number and we are putting 0 here, it is not a 3-digit number any longer. It will be a 2-digit number. So this way you proceed, you will find all the numbers. Now see question 3. How many different numbers can be formed with the digits 1, 3, 5, 7, 9? You see that 5 digits are there and we have to form a 5-digit number with these 5 digits. So this can directly be done in 5 factorial ways. Very easy. This is very easy. Now the main important thing is that what is the sum of these numbers? So see how the numbers are coming. Suppose I am writing number 1, 3, 1, 3, 5, 7, 9. One number is there. If I am writing then 3, 1, 5, 7, 9 like this. Okay, just we have to see how many times 9 is coming at unit place. So for finding the sum of all numbers, we have to sum up all the digits at unit place first, then at tens place, then at hundreds place, then thousand place, then 10,000 place. So at unit place, suppose at unit place I have to see 1 is at unit place. I am fixing 1 at unit place. Okay, see remaining 4 places can be filled up. If I have fixed 1 at unit place, it can be filled up in 4 factorial ways. which is 24. So 1 is coming 24 times at unit place. Same way, 3 is coming 24 times at unit place. So sum of all the numbers at unit place is 24 into 1 plus 3 plus 5 plus 7 plus 9. This is sum of the digits at unit place. So it is coming out to be 24 into 9, 16, 25. So it is coming out to be 600. So sum of all digits at unit place is 600. Same way, sum of all the digits at tens place will be 600 into 10 I have to write. Then at 100 place it will be 600 into 100. This will be 600 into 1000 and 600 into 10,000. So we can find the sum of all the numbers taken together, and this is coming out to be like this. So follow this technique. How many times 1 is coming, how many times other digits are coming at unit place, and then find the sum of all the digits at unit place, and just follow this process. You will get the sum of all the numbers. See, in the first question, in how many ways 5 boys and 5 girls be seated in a row if no restriction is there? You see here 10 students are there, and that can be seated in a row in 10 factorial ways. How this is coming 10 factorial? Because it is 10p 10. If you just calculate this, this will come out to be 10 factorial divided by 10 minus 10 factorial, that is 0 factorial. So actually it is 10 factorial. So no restriction is there. We have to just arrange the total number of things in the total number of resources available. 10 seats are there where 10 students to be seated, that is 10 factorial. Very simple. Now the restriction arises, all the girls are together. This is very particular case. We just name the method of solving such type of problem as string method. What we do, we just take all the girls as one unit, G1, G2, G3, G4, G5. 5 girls as one unit. I just say that they have been kept in a bag. Okay, so 5 girls in the bag and the 5 boys are there around B1, B2, B3, B4, B5. See now how many items are there to be arranged. 1, 2, 3, 4, 5, 6. So how to calculate how many items are left? The rest items plus 1 unit of combined together. So this is 5 plus 1. So 6 items are there that can be arranged in very simple 6 factorial ways. You can find, but inside the bags, girls can be arranged among themselves. 5 girls are there, so 5 girls can be arranged among themselves in 5 factorial ways. So these are the ways where all the girls are together. So whenever you have to deal with such type of problem, you combine the things which are always together in a bag and take the rest things, add the bag as one item, take the total items, arrange them, and now arrange the items in the bag also. So this is clear. The third question is that no 2 girls together. That is also important type. We tell this type of problem as gap up method. How? Because there is no restriction for the boys. Firstly, we will be concerned about boys. B1, B2, B3, B4, B5. 5 boys are there, no restriction about the boys. So boys can be arranged in 5 factorial ways, not a problem at all. Now see, we don't have to keep 2 girls together. So see how many places are there for the girls to be seated so that they are not together. See here, they can be seated here, 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 here and here. 6 places are there where the girls will be seated, then no girls will come adjacent to each other. So 6 places are there where we have to seat 5 girls. That can be done in 6p5. Okay. If you don't want to use the permutation, you can just write 5 factorial for boys and girls. See, how can we just seat the girls? 6 places are there and we have to seat 5 girls at the places. So the first girl can be seated in 6 ways, second girl in 5 ways, third girl in 4 ways, and second girl in 3 ways, and the first girl in 2 ways. So actually, if you are not using the term permutation, you can just apply the basic fundamental principle of counting. That 6 options are there where we have to make the 5 girls to sit. So these are the ways we can do. So I think this is clear. No 2 girls together, just follow gap up method. Sit where no restriction is there, just apply that permutation there, and now find how many gaps are created in between. So it is a rule that if 5 things are there, 6 gaps will be there in a row. 10 things are there, 11 gaps will be there in a row. But in circular permutation, we will see that 1 gap will be lesser. That we will see later on. Okay. Now see, 2 particular girls are always together. That means 2 girls. Suppose G1 and G2, they just insist that they will be sitting all the time together. So what we will be doing? We will be keeping them in a bag. String method. 2 girls in the bag. How many items now left over? 2 girls have been taken. 10 students were there. 8 students are there. Now 8 plus 1 bag. That can be arranged in 9 things. 9 factorial ways. Okay. Now these 2 girls can be seated. They can change their positions here or there in 2 things in 2 factorial ways. So 2 particular girls are together is very much clear. That was question number 4. And see, 2 particular girls are never together. This is a technique for never together. Never together means never together. Firstly, we have to see what is the meaning of never together. Never together means total number of ways minus together ways. Ways were together. So these 2 particular girls are never together. Total number of ways without restriction we have seen is 10 factorial. And 2 particular girls are together we have found in part number 4 as 9 factorial into 2 factorial. So it is coming out to be 9 factorial into 2 factorial. So this is total number. So never together is always you find total number of ways minus the number of ways in which they are together. This is clear. Never together, together is clear, and gap up method is also clear to you. So no 2 boys together, no 2 letters are together, no 2 things are together. You just follow gap up method. You will find your problem in a very convenient way and you can solve it very easily. Hope this restricted permutation is very much clear to you. Now we will see how the letters of the word can be arranged if certain things are alike. It can be any situation when something are of same type. We will follow the technique which we are going to discuss here. See, the number of permutation of n things where p are of one type, q are of another type, and r of another type, they are alike. Then total number of ways of arrangement taking all the letters at a time. The important thing is we are taking all the letters. So it is n factorial divided by p factorial into Q factorial into R factorial, because P things are alike, Q things are alike, and R things are alike. So this is very important theorem. We will just see the application of this theorem in the questions given here. First question, how many ways can the letters of word India be arranged? See, firstly you see how many words are there. How many letters are there? 1, 2, 3, 4, 5. So we have to write 5 factorial divided by, what is alike here? You see here 2 i's are there. So it will be divided by 2 factorial and no other thing is alike. So the total number of ways of arrangement of the letters of the word India is 5 factorial by 2 factorial. You can do this. Now come to question number 2. Find the number of arrangement of the letters of word banana in which 2 ends are not appear adjacent to each other. What does this mean? We have to follow the gap up method we have discussed earlier. See, firstly you write banana. See. So total number of arrangement is going to be 4, 5, 6. 6 factorial divided by, you see 3 a's together. So by 3 factorial and 2 n's together. This is the total number of ways. But we have to see that no 2 n's are together. So we will just get rid of the n and arrange the rest things. 1, 2, 3, 4. 4 things can be arranged in how many ways? 4 factorial ways. And out of these 4 things, you see 3 a's are there. So divided by 3 because 3 alike things are there. So now we have just arranged B, A, like that. B, A, A. This can be arranged in that many ways. Now gap up method you follow. Just I said you, in between 4 things we got 5 places. So 5 places are there where we can say 2 n's. So that can be done in, out of 5 places we have to arrange 2 things. So 2 places can be taken in 5 ways. Okay, but you see, as we have to arrange the 2 n's and they are alike, so by 2 factorial. So this is the total number of ways in which the n's do not appear adjacently. Okay. Third question, how many arrangements can be made with the letters of the word mathematics? Just firstly write the word and see its composition. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are there. So total arrangement will be 11 factorial, very easy. And see now the repetition, 1m, 2m. 2 m's are there, so by 2 factorial. Now you see 2 a's are there, so by 2 factorial. Now you see 2 t's are there, so by 2 factorial. And apart from that, I think nothing is repeated. HEICS, that is all different. So that is the total number of arrangement of the letters of the word mathematics, taking all at a time, all 11. Out of this, 2 were alike, 2 were alike, 2 were alike. So this is n factorial by p factorial, q factorial into r factorial, as we discussed in the basic theorem. So this is the total number of arrangement of the word mathematics. In how many of them vowels occur together? Now just pick up the vowels. What are vowel here? A, E, A, and then I. So 1, 2, 3, 4 vowels are there. They are together. I just told you that this is string method. You just keep all the vowels together. That is A, E, then A, then I. That is a vowel. If we are taking all the vowels together, out of 11, we are separating the 4 items. What we are left with? 7 items plus 1 item. So, in total, we can arrange them in 8 factorial ways, because 11 things are there, out of which if we are subtracting 4 things, we are left with 7 things. And as we have kept all these things in one bag, so total 8 things, and 8 things can be arranged in 8 factorial ways. Out of these 8 things, we have to see whether something is repeated or not repeated. See, 2 m's are repeated. What 8 things are there? I'm just writing here. So we are just left with M, T, H, M, T, C, S. 1, 2, 3, 4, 5, 6, 7 and this. See, in this 2 m's are repeated, so by 2 factorial. Now 2 t's are repeated, so by 2 factorial. So this is the arrangement of the 7 thing plus 1 thing, 8 things. And now these 4 things can be arranged among themselves in 4 factorial ways. But see, something is repeated or not. Yeah, 2 a's are there, so we can write by 2 factorial. So this is the total number of ways under the conditions given here. Vowels occur together. We have separated vowels together. String method we are following here, and just arrange the 8 items, out of which 8 items. Firstly, we are concerned with these 7 items plus 1 bag. So we are not taking whatever is repeated here. So out of 8 things, 2 m were repeated, I did here. 2 t's are repeated, I did here. And in these 4 things, I can arrange them in 4 factorial ways, but out of them 2 a's are repeated. So by 2 factorial. Hope this concept is now very much clear to you. We will see circular permutation, that if certain things are arranged in a circle, how many ways of doing that is possible. See, n things can be arranged in a circular fashion in n minus 1 factorial ways. What we do in circular permutation, we just keep one thing fixed, and the remaining n minus 1 things are revolved around that. So the total number of permutation of arranging n things in a circle is n minus 1 factorial. Just remember this. See, first question, in how many ways a party of 4 boys and 4 girls be seated in a circular table so that no 2 boys are adjacent. See, there is no restriction about the girls. So girls in a circular table, 4 girls are there, so they can be seated in a circular table in 4 minus 1 factorial, that is 3 factorial. Okay, now the girls are like this, girls. Okay, how many places are there between the girls where the boys can be seated so that no 2 boys are together? See, how many places are there? 1, 2, 3, 4. Again, it is coming the same thing. Okay, it is circular fashion, so we cannot put one place here. In a row, in between 4 things, 5 places were there. But in a circle, in between 4 things, 4 places are there only. In that 4 places, 2 boys can be seated in 4p2 ways. Girls have been arranged in the circle, and now as we have to follow the gap up method, that means no 2 boys to be together. So boys can be seated in the remaining 4 places in 4p4 because 4 boys are there. Sorry. So we can just write 3 factorial into 4 factorial of the arrangement of the boys and girls. Second question, find the number of ways 10 different flowers can be strung to form a garland, so that 4 particular flowers are never separated. They are never separated. That means 4 flowers are always together. We will just keep the 4 flowers in a bag. 4 flowers have been kept in a bag. Remaining 6 flowers are there. So 6 flowers plus 1 bag, total 7. 7 items can be arranged in a circle in 7 factorial ways, because in the case of the garland, no clockwise and anti-clockwise differentiation is there. That means we are not getting different things if we are changing the clockwise and anti-clockwise item of a particular way. We are not getting any change. So the total number of ways will be half of the deck, because in n-1 factorial we are taking care of the clockwise and anti-clockwise position also. So in the case of the garland beads, it is n-1 factorial by 2. 4 flowers are together in this F1, F2, F3 and F4. They are kept in a bag. Remaining 6 flowers are there. So total 7 items are there, and that 7 items can be arranged in 7 minus 1 factorial by 2. Why? Because in the case of the flowers, in the case of the garland beads, no clockwise and anti-clockwise position is there. In n minus 1 factorial of circular permutation, we take care of the clockwise and anti-clockwise position with respect to a particular thing. But here anti-clockwise and clockwise position is not different. So this is 6 factorial by 2 factorial. And now these 4 garlands, 4 flowers in the bag can be arranged among themselves in 4 factorial ways. So that is the total number of ways of arrangement. Now see question number 3. In how many ways can 7 persons sit around the table so that all shall not have the same neighbor in any of the 2 arrangements? Very simple. 7 persons in a circular table can be arranged in 7 minus 1, that is 6 factorial. But they are saying that a particular person, suppose John is there and he is surrounded by Sohan and Mohan. Okay, a particular arrangement I am taking, but they are saying that no same neighbor should be there. That means once Sohan is here, Mohan is here, once it will be like John is in between and Mohan is here, Sohan is there. So in half of the cases there won't be the same neighbor. So that will be 6 factorial by 2 factorial. You can say 2 factorial or 2 by 2. In the half of the cases they won't be having the same neighbors. Now question number 4. A round table conference to be held between the delegates of 20 countries. How many ways they can be seated if 2 particular delegates are always together? Very simple case. You just keep 2 guests in a bag. Remaining 18 guests are there. 18 guests plus 1 bag. 19 things that can be arranged in 19 minus 1. Because n minus 1 factorial. And these 2 guests which are always together, can they change their positions in 2 factorial ways? They are never together. As we have earlier discussed, that never together means total ways minus together ways. Total ways of arranging 20 delegates is 19 factorial, 20 minus 1 factorial, that is total ways, minus together ways. What is that? Together ways we have found out 18 factorial into 2 factorial. So in this way you can find the problems of circular permutation easily solved. You just follow. In a nutshell, I am saying that total number of arrangement is n minus 1 factorial. when we are taking care of anti-clockwise and clockwise things. But in the case of the garlands and beads, it is n minus 1 factorial by 2. Hope you are understanding the circular permutation.
If you like my videos, please subscribe my channel and share my videos.